Good afternoon. Welcome to the January edition in our supply chain webinar series. During the presentation today, if you have any questions, raise your hand or type in a question. If you have a microphone or you use the dial-in connection and I see it, I'll turn your speaker on and you can ask the question of me and we'll replay it to everyone. So here we go. Calculating forecast accuracy. What we're going to look at today is why it's important to track the accuracy of our forecast. Then we're going to look at one measurement technique called standard deviation to measure forecast accuracy. And when we get through that, we're going to look at how you can take the output from the standard deviation calculation and use it to help you in supply chain management issues. So, why is it important to constantly monitor forecast accuracy? Back at the turn of the 20th century, a hurricane hit Galveston, Texas in 1915. And as you can see from some of these archived pictures, the devastation was very dramatic, very severe. But the key thing of this Galveston hurricane was the estimated death toll. They estimate that between 6,000 and 12,000 people perished as a result of that hurricane. And to this day, that hurricane is the all-time deadliest hurricane to hit the United States since we've been recording these things. Now, fast forward a century to 2012. Hurricane Sandy comes ashore in the most populated state in the nation, New Jersey. And New Jersey and Delaware and New York all got clobbered with this massive hurricane. The amount of material damage was substantial, on the order of what happened in Galveston, Texas 100 years prior. But the significant change was the total number of fatalities. Whereas Galveston was 6,000 to 12,000, the fatalities from Hurricane Sandy were 285. The reason for this dramatic drop in fatalities was the fact that our forecasting of hurricanes has improved exponentially in 100 years. The reason that forecast of hurricanes improved is that every time they forecasted a hurricane, they would look at what actually happened, compare it to their forecasting technique, and find new ways to make adjustments or improvements in those forecasting techniques. One of the biggest improvements in those forecasting techniques was a satellite in orbit that could take pictures and track these hurricanes as they were progressing across the Atlantic. So if we look at that in the context of the forecast that we have to deal with on a day-to-day basis from our sales and marketing folks, it's the same issue. If we monitor the forecast accuracy and we use that to drive improvements in the ongoing forecasting techniques that are being used, over time, our ability to forecast what's going to be sold for any of our products or services will improve. And the better we can forecast, the better we can prepare for it. So that's why measuring forecast accuracy is important on an ongoing basis. Excuse me. Okay, so let's look at how you measure forecast accuracy. One of the techniques we're going to look at is calculating the standard deviation. And there are many techniques for calculating forecast accuracy. This just happens to be one of them. If you take a look at this family reunion picture, a group of people, with the exception of the little girl in the stroller, all of these individuals are adults, different genders, male, female, different ages, some from a different ethnic background. But if we took the height of each one of these people, what we would find out is that on average, on a bell curve distribution, like I just superimposed here, on average, the average height of the people in this group would be 5'7". Now, most of the men would range from 5'7" to 5'10", 5'11". Most of the women would range from 5'2" to 5'7". But within 1 or 1.5 standard deviations, it would account for most of the people in this group. There are some exceptions, as there always are. The guy in the left-hand rear, he's most likely about 6'4". He would be to the far right-hand side of the bell curve. The woman second from the right is most likely about 5 foot tall. She would be on the far left-hand side of this bell curve. But most of the people would center somewhere around that 5'7" average height. So, how do we use this in our measuring forecast for products? Well, let's take a look at that. And I apologize for this cough. I was out shoveling snow this morning, and evidently it's catching up with me. All right, so here we have some information for a 10-month period of time, the forecast which came out of our sales and marketing folks, and the actual demand. If we look at the actual demand and relate it back to the picture of the family get-together, the actual demand would relate to the actual heights of all the people that came to that family reunion. The average forecast would relate to the average height of all of those people. So in this case here, our average forecast, 1,000 a month for 10 months, January through October. Our actual demand would be what we actually sold each of those months. Now, the standard deviation formula. It's a straight algebraic formula. Here's how it works. It is the sum of the actual demand for each time period minus the forecast for that time period. And then when you get that result, you square it. You multiply it by itself. Then you divide that by the number of periods. Take the result of that, and the square root of that is your standard deviation. So let's look in more detail here. The absolute error is how much any month's actual demand varied from the forecast. Forget about the plus or minus sign. We're looking for the quantity, not whether it was negative or positive. So in January, it deviated 200 pieces. In February, it was dead on the money. In March, it deviated 200 pieces. Now, January was a plus, March was a negative, but we're not worried about that. We need the number. Once we get the absolute error for each time period, we square that, multiply 200 by 200 is 40,000. Now, we've got the data that we need to finish the rest of the standard deviation calculation. So we sum up all of those errors squared by time period, and that comes up to 400,000. Then we divide it by the number of periods minus 1. In this case here, n minus 1 is to maintain the statistical validity of this because we don't have a lot of data points. Here's the way that works. If you have 30 or more data points, you use the total number of data points. If you have less than 30 data points, you use the total number of data points, in this case 10, minus 1. It maintains the integrity of the data. So you divide 400,000 by 9. The result of that calculation is 211, the standard deviation from the average forecast of 1,000. All right, so now we went through all of this math. What do we do with that 211-piece standard deviation? So here's where we go from here, how we take that and use it in supply chain management. Here we're back to the bell curve. Remember the bell curve from the attendees at the family reunion? The average was right in the middle. For the height of the people, it was 5'7". For the average of our forecast over this 10-month period, it's 1,000 units. Now, if we're trying to make sure that whenever customers call, we can ship from stock, if we put 211 units of safety stock in addition to the 1,000 units that we try to carry on hand all the time, what that means is that 84% of the time during any given month or over that 10-month period of time, 84% of the time we would be able to fill that order from stock. Now, if management has said that they want a 95% on-time ship from stock, well, we can take standard deviation, that 211, we can figure out there's a whole table, a mathematical table that shows if you want 95% accuracy or 95% coverage under this bell curve, you need about 1.8, 1.9 standard deviations. So you would say 1.8 times 211, which is our standard deviation quantity, and you'd be able to say to management, we need 400 pieces of safety stock in addition to the 1,000 pieces of stock that we normally carry. With that 400 pieces of safety stock, 95% of the time, you'd be able to fill an order from stock. Now, the interesting thing here is when you have safety stock, management often comes back and says, well, that's really too much safety stock. It's costing us too much to meet that service level. What can you do about it? Using this data, the standard deviation, what we can do is say to management or to the sales and marketing folks, if we want to reduce the amount of safety stock, we have to reduce the value of the standard deviation. If we want to reduce the value of the standard deviation, then we need to use a different forecasting technique or improve the one that we're currently using, because back here in May, we shipped 400 more than we forecast. That's 40% more. Yet in August, we shipped 300 pieces less than we forecasted. So we can use the standard deviation tool both to tell us how much safety stock to have, and we can also use it as a driver to motivate management, motivate sales and marketing to continue to improve their forecasting techniques, because the better their forecast is compared to what we're actually doing, the smaller the standard deviation is, the smaller the standard deviation is, the less safety stock we have to have. So, in a nutshell, that was soup to nuts why it's important to measure forecast accuracy. And remember, it's all about improving the techniques that we are using to forecast the data, whether it is weather, when hurricanes are going to arrive, or how much of a product we're going to sell month to month. Then we looked at one tool, and there are several, for calculating the accuracy of a forecast in this environment, and that was the standard deviation. And from there, we wrapped up with, okay, now that we have the standard deviation, how can we use that to figure out how much safety stock to put in to meet management's requirement for customer service level, and or we can use that to drive further improvements in the techniques and accuracy that sales and marketing is using to forecast the product.